We're going to have Jeff talk about wheat leaf rust. Thank you, Jeff.
Thank you, Domini. Before I start, I'd encourage you, as that questioner did, please, if you have a question for Daniel or Kith or myself or Svetlana, type it into your screen, and there is an opportunity after this presentation for a short amount of time to answer questions. So I'd encourage you, please, to ask a question if you have one. I briefly want to quickly touch off on, I mentioned at the beginning about some new leaf rust pathotypes that occurred in 2013, and Keith has already told us about the barley leaf rust new pathotype. In 2013 we had an incursion of wheat leaf rust, a brand new pathotype in Western Australia, and you can see the designation on your screen. I'm not going to run through that for fear of tripping over, but this, just to make the point that this was an incursion rather than a mutation, as occurred with the barley leaf rust. This wheat leaf rust pathotype is thought to have come from the eastern states across to Western Australia, and it really does indicate the importance of understanding biosecurity and being careful about, and particularly in concern of the diseases like the rusts, being careful about carrying or moving diseases from other places into Western Australia. Certainly this leaf rust pathotype was the first occurrence of some new virulences in Western Australia, and including to LR13, which had potential impact on varieties such as mace, wildcatcham and korak. And if we have a look at the two pictures at the bottom of the screen, we can see on the left-hand side some glasshouse trials that were run by myself and Manisha Shankar earlier in the year. And it shows the glasshouse response to this new pathotype, and we can see that several varieties are exhibiting rust infection that previously we might not have expected this to occurring. Bearing in mind, though, of course, that some varieties are still exhibiting good levels of resistance, depending on the genetics of those varieties. If we have a look on the right-hand side, this is some mace, and the comparison there is between the 104 is the pathotype that was present and resident in Western Australia up to 2013, and is still obviously present in Western Australia, but compared to the response to the new 76 pathotype, and we can see that mace's response is certainly become more susceptible. And this was a concern, obviously, given the area sown to mace and other supposedly increased susceptible varieties. So given the very dry summer and the fact that we didn't really have any expression of disease this year, we took the opportunity to do some trials looking at the potential impact of this new pathotype on varieties such as mace by carrying out inoculated trials in areas that were apart from the wheat belt. So at our Carnarvon Research Station, Manisha Shankar carried out a yield loss trial looking at the response to this pathotype across a range of varieties. This is a high disease pressure site. Infection is introduced early in the season. Early in the season, as both sprayed inoculum and as susceptible spreader rows, and so we have a very high disease intensity from early in the season. What we can see from the graph is that mace developed damaging levels of leaf rust, but significantly less rust than the susceptible controls, and stiletto is an example of one of those susceptible controls. When this trial was taken to yield, the impact of that level of rust on mace was a significant yield loss, approximately 30% yield between the untreated and the full control treatments, which is a significant impact of this new pathotype on mace. It was, however, less than the susceptible variety stiletto, which had more than 50% yield loss. A similar trial conducted at Medina Research Station, but the difference here was that we applied rust at a later stage without any spreader rows. So we had 2 foliar applications of rust applied at around flag leaf emergence. So this was a later disease occurrence. Again, we saw severe disease in the susceptible control stiletto, up around 50% of the leaf area affected at grain fill. Leaf rust was present in mace, but at low levels, around 5% of leaf area affected. Unfortunately, we don't have the yield results for this trial at the moment, but it is interesting to see that the impact of this new pathotype. At the moment, there have been no reports of this new pathotype of any leaf rust, wheat leaf rust from the field this season, and so we don't know how well it has established. But we do know from these trials that under high disease pressure, with early infection from stem extension, mace can exhibit significant rust infection and associated yield loss. However, that degree of yield loss is less than in susceptible or very susceptible varieties. Under lower disease pressure, with rust occurring from around flag leaf, mace exhibited rust, but at much lower levels of disease, and the impact of the rust in that occasion might be considered to be much lower. I guess the message that comes out of this is that it's important in terms of the area that's sown to mace in our cropping system that we manage our green bridge, if there is one that occurs, to avoid that early rust pressure, and that if rust does occur, it is possible that, or it is likely that we may be required to control leaf rust in varieties such as mace and wild catching. I must acknowledge that as part of both the wheat leaf rust and barley leaf rust pathotype identification, the Australian Cereal Rust Control Program and the rust monitoring activities that program carries out through Sydney University are extremely important, and I would encourage all of our audience to submit samples to that program of rusts on any cereal crops at all times during the year, because it is extremely both of these leaf rust pathotypes exhibit why it is important to keep abreast of what our pathotypes are in the cropping system.
Thank you very much, Jeff. And again, we'd like to acknowledge the help from DAFWA and GRDC for being able to present this webinar to you. Now, we have a few questions from the floor. One of our questions is about the graph with the Carnarvon yield loss. What is times 1 and 2?
They are time 1 and 2. My apologies for not explaining that. Time 1 and 2 are actually times of assessment.
Okay, thank you, Jeff. The next question, again for Jeff, is how long is an effective fallow to break a green bridge, considering the need for feeding sheep?
Well, a couple of things. Feeding sheep on the green bridge is actually effective. Is an effective methodology. I would suggest that we would normally consider sort of 3 to 4 to 6 weeks as an effective period. We need to remove that inoculum before the crop emerges, and certainly we've seen in seasons where green bridges have occurred, and then we have a dry period immediately pre the seasonal start of the season, that rust pressure diminishes. So I would consider a 3 to 4 week period as essential, with no green material, for the diminishing of the rust inoculum.
Thank you. We have a question in regards to what is mace's current leaf rust resistance rating? Is it MS or MSS?
The consideration is that I understand that it is moderately susceptible to susceptible, as indicated, and that certainly is indicated or supported by the responses in this trial. So MSS I would consider it to be currently. Manisha Shankar, who does the screening activities, will be providing the the most updated information to the variety guide, and that information will be available very shortly. But at the current time, we would consider that it's prudent to consider mace as a moderately susceptible to to this new pathotype, bearing in mind that this pathotype, whether or not this pathotype becomes dominant within Western Australia.